worth of the option, or evaluating the worth of the option and then concluding whether the option is overpriced in the market, or is it underpriced, or is it more aptly priced. So this is what we are typically looking at when we are doing the valuation process. And there are two major models which are heavily engaged to do the valuation of the options, and one of them is the binomial trees option. So this session I'll try to focus on using the binomial trees to typically perform the valuation of the option. So to start with, or probably as an agenda, I would like to look at first of all a one-step binomial tree model. Right, I'll tell you what we mean by a one-step binomial tree model, wherein I am looking at an important mechanism of evaluating the options using what we call as the no arbitrage argument. Using the principle of no arbitrage, I would like to find out the value of this particular option. Then I'll introduce you to another valuation mechanism for finding out the value of the binomial, or by using the binomial trees itself. Instead of no arbitrage argument, I'll try to find out the value of the option using the risk neutral valuation methodology. Even this also is using the binomial trees itself. I'll try to use the risk neutral valuation methodology and then try to find out the value of the option. These two initially I'll showcase it using a one-step binomial tree itself. Once a comfort comes on one-step binomial tree, then I talk about two-step binomial tree approach. What is the kind of difference we bring out compared to a one-step binomial tree approach into a two-step binomial tree approach? And these two kinds of scenarios I would be working out both for evaluating a call options price as well as for a put option itself. And even I would be talking about how would this tree be constructed or being used both for American options as well as European options. Even that would be considered as a part of our valuation exercise. Then I would like to bring in the concept associated with delta, which is more to do with the sensitivity of the option. So how do I really look at evaluating the sensitivity or the delta using the binomial tree approach? Then how do I really get into the volatility assessment? How do I really look at the volatility assessment using the binomial tree approach? And instead of, let's say, one step, two step, if the number of steps really increase drastically, how does it get translated, or how complex this binomial tree becomes, and is there any other mechanism to address this kind of an approach? Adjust this binomial trees is something which we would look at. And finally, I would also try to spend some time in terms of not just the options on stocks. Probably how would I look at an option on a stock index? How do I find out the valuation for that? Just a quick intro to all these. How do I find out the value of the options on currencies? How do I find out the value of options on futures? Though we'll spend more and more time on these things at a later stage, here I just want to give you a quick summary or introduction using the binomial trees. How do I really spend time in terms of understanding the values of each of these instruments? So with that as a base, let's get started with the one-step binomial tree approach to value the option on a stock. As I really said, binomial tree option is one of the two major models that is heavily used to find out the value of the option. The other one being a Black-Scholes approach, which I'll take up slightly at a later point. But the binomial tree approach is one of the major mechanisms today that is being used for valuation of the options. The prime assumption this model goes with is the stock price, whatever is coming at any point in time, it follows a random walk. So it can either go up or go down. So today if the stock price is S0, after let's say 1 month, it can either go up to some SU or it can go down to SD. That's a major assumption that is drawing. There is some probability that it can go up by some percentage, right? Probably there could be a probability P that it will go up by some percentage. There could be a probability 1 minus P that it could go down by some percentage. That's one major assumption that it is going to have with. And let's say based on that, if I am taking currently, let me assume that the stock price today is some 100 bucks. Today the stock price is 100 bucks. I am assuming that let's say after 3 months, it can either go up by 10% touching 110, or it can go down by 10% touching 90. And let's say in the market there is one 3-month expiry European call option that is available, probably let's say for 105 bucks in the market. The strike price is 105 that is available for me, which is going to expire in 3 months. Now, in case the stock price really touches 110, because the strike price is 105, from a call option standpoint, the long call is going to exercise this particular option. So he is going to have a payoff of 5 bucks. Here he is going to have a payoff of 5 bucks. But in case the stock price comes out to this 90, then this option will not be exercised. It would be expired because it requires buying the stock at 105, which the long position will not do, which will result in expiring of the call option. So the value here, the payoff here is going to be 0. So these are the two possible movements of the stock price, and these are the possible payoffs that are coming from the option. And we are making another assumption here. When I am going with a no arbitrage argument, I am saying in case of a no arbitrage argument, I am making an assumption that the arbitrage opportunities do not exist. And under that, the arbitrage opportunities do not exist kind of an assumption, I am creating one portfolio. The portfolio consists of X number of shares plus one call. The portfolio typically consists of X number of shares and one call, and the X is something which I am more interested in finding out, but the combination is in such a way that after 3 months the value remains the same, whatever may be the share price going up or share price going down. Right? The portfolio is created in such a way that there is no uncertainty of the position at the end of 3 months. So it's as good as saying if the share price goes to 110, I have X shares. So X times 110 I have one call option. Whatever is the worth of the call option, on this day, the worth of the call option, let's say, is going to be 5. So the worth of the call option at this point, so X shares